Welcome back to the Training Babble podcast. I'm your host, Dave Schell, and once again, I'm joined by Dr. Phil Batterson. Dr. Phil, thanks for being here.
Thanks for having me back, Dave. These conversations are always something I look forward to. So I'm hoping that we can keep this up, for quite a long time.
Yeah, absolutely. I think there'll always be some aspect of physiology that people have questions about or that they want some clarification on, and so we should be able to do this for a while. And so if you're not up to speed, we've been doing a series of mini podcasts, trying to stick to 20 to 30 minutes, and each one focusing on one aspect of physiology, and we're calling them fast physiology. So I think this is probably our 7th one, if not more.
Yeah, something like that. I know, it's always hard to tell like which ones have been released and which ones are backlogged, but yeah, we certainly have at least, I think, 7 published at this point, and we have a lot more that are kind of waiting in the wings, as it were. So if you guys do have any questions or anything you want us to touch on, please let us know, because we're always looking for topics to talk on. Dave and I both have opinions on all of this sort of stuff, so we like to share them, and especially within the 20 minutes is kind of fun because it makes us be a little bit more succinct.
Yeah, absolutely. And again, if you haven't been keeping up, we are kind of going back and forth between Training Babble, my podcast, and Critical Oxygen, Phil's podcast, which you can either find in the show notes or you can anywhere you find podcast, just Critical Oxygen.
Yep.
So today we are going to talk about fiber type, and this is something that's always been kind of interesting to me in that it took me a while to kind of make the connection between these energy systems and fiber type and kind of how they relate. And so I think a good place to start is just I think a place that I need clarification on, and I can never like keep up. Like I think at one time it was like type 1 slow twitch, type 2A fast twitch, and then type 2B fast twitch. And now I think it's type 2X fast twitch, right? So I guess let's start there.
Yeah. Let's do a definition of fiber types first. So your muscles are made up of fibers, and within those fibers, there's delineations between really 3 different primary types of fibers, and those can be broken down into 2 actually. So you have your type 1 fibers, which are quote unquote slow twitch. Then you have your type 2 fibers, which are quote unquote fast twitch. Within your type 2 fibers, you have type A fibers, which are we'll get into it, but they can be a little bit more aerobic. And then you have your type 2X, which are more non-aerobic or anaerobic. You've probably heard that term thrown around a lot more. I use non-aerobic just because oxygen is always present and always being used. So it's just a little kind of me being a stickler with things. So there's never a time that you're actually anaerobic. You're just using non-aerobic sources to derive ATP. So to kind of let's talk a little bit about the history behind how these fibers, I guess, have been described in the past, because that's really how we've gotten to this idea of like type 1 slow twitch or type 2A, type 2X. So let's break it down first. So if we have there are a number of different ways you can actually delineate between fiber types, and one of them is histochemical staining. So essentially what you do is you take a cross-sectional area of the muscle, cut it in half, and then you using like certain colored dyes that will bind to particular proteins.
Right.
And from there, you can kind of count and delineate, the different muscle types, right? The different fiber types.
And I think that's a good point, just to kind of pause for a moment and just explain that. Like when we talk about fibers, it's not like you have a fast twitch muscle or a slow twitch muscle. It's like these muscles are made up of both types of fibers, or all 3 types of fibers in just different proportions, correct?
Yeah, absolutely. So that is perfect. And so before we get into actually how we, technically figure out what the fiber types are, let's actually take a step back and let's say, okay, well, what are the characteristics of a type 1 fiber? A type 1 fiber is generally something that is more fatigue resistant. So from what you were asking, Dave, is like all muscles are made up of all different types of fibers, and that's why we have the ability to have really, really low force output contractions, like with our legs, right? Like you can be walking really slowly, and that would be
Right.
considered low force output contraction, or you can sprint. So you have the ability to do all of those different things because of the different fibers within that muscle. And different muscles have different proportions of fiber types. So our postural muscles, so muscles that are lining our spine, muscles that are engaged in our core, our heart, for example, are all very, very high amounts of type 1 fibers because your postural muscles, you do not want to fatigue,
Right.
right? You don't want your heart to fatigue. If your
Yeah.
heart fatigued, you'd be screwed, right? So so you can think about it as like the proportion of muscle fibers is going to be directly related to the function of that muscle fiber. And this is something that we talk about in my exercise physiology class, or at least did, is that function and physiology are tied to each other, kind of in this like cyclic pattern where function dictates the physiology, and then the physiology kind of dictates the function, and round and round we go. So if you have for example, if you then had a muscle that was involved in something like jumping or sprinting or something like that, like your calf, you would expect it to be then more type 2 fiber dominant.
Yeah. And I'm thinking back to when I was in culinary school, and maybe this is not correct, but I think I recall at one point it being explained to us that the reason, like chicken, leg meat is dark meat because it's more fast twitch fiber, more myoglobin, and then breast meat, because they're not flying birds, would be white, because it's less active. Is that accurate, or is that like a stretch?
It's flipped actually.
Okay.
So because the legs are being used so much walking around and doing
Ah,
those sort of things, they
that's
actually
right.
have more mitochondria and more myoglobin. And both the mitochondria and myoglobin have red hue to them, which then looks brown or dark.
Yeah.
So that's where the dark meat comes from. That's why cows are mostly red. How many times do you see a cow sprint? You
Yeah.
very rarely, right?
Yeah.
And you wouldn't, just because of the way that fiber types are actually kind of mixed within, you don't see this as much in mammals as you do in like birds, for example.
Okay.
But like most mammals, their meat is very, very red. And I can guarantee you, because I've done this, if you take a muscle sample from a human, you can't delineate with the naked eye, like, oh, that's dark meat and that's light
Right.
meat, right? It just all looks like
That's
hamburger,
that's
essentially.
disgusting.
Yes, I
I
know.
think we just crossed the line.
Yeah, yeah. Not for not for eating purposes, for analysis purposes during my PhD. But that's what it comes down to. And what's really interesting about this is we do say, oh, well, type 1 fibers are like they're associated with fatigue resistance that comes along with much more mitochondrial volume density. But all of our muscle fibers have mitochondria. All of our muscle fibers have the ability to do glycolysis, to do oxidative phosphorylation, to do phosphocreatine breakdown. So we have the ability to do everything. It's just the extent to which these fibers can actually do that.
And so now, like, I don't know if this is old thinking also, but with is it the 2X fibers that are kind of more trainable, and whatever you do the most, it can kind of lean one way or the other?
Type 2A.
Type 2A. Okay.
So yeah, so let's actually um go and say why it's not type 2B.
Okay.
So there was this misconception, or and not even a misconception, but a misidentification of the fiber type, type 2B versus type 2X.
Okay.
And if you're looking at a continuum and you're looking at your type 2 fibers, you have type 2A, which is the most closely related potentially to type 1 fibers. Then you have type 2X, which is in the middle, and then you have type 2B, which is after that. And in humans, we do not express it's the myosin heavy chain isoform, which is really kind of given us that 2X, 2A, 2B. We do not express type 2B myosin heavy chain isoforms.
Oh, interesting. Okay.
So it was, yeah. So I think this was first, something that was identified in either like murine mammals, so mice, rats, something like that, and then it was just kind of assumed that the same thing would happen in humans,
Right.
and that's not actually true. So anybody who does say type 2B, it's not that they're just inherently misleading you. It's that they probably learned it when we didn't know that humans didn't actually express that. So humans only express type 2A and type 2X. And then further down, like the power strength ratio index are those type 2B fibers.
Okay.
And it's the type 2A, though, if we kind of get back to it on this continuum, it's the type 2A that when you train them, they can either go a little bit more towards type 2X, so they can be more glycolytic and more kind of phosphocreatine centered, or they can look a lot more like type 1 fibers. And when I say that, I mean they can develop a very, very robust mitochondrial population, which would make them more fatigue resistant because the more oxygen we can use, the more fatigue resistant we can be. Or they can, if you do a lot of sprint training or, strength training and other things like that, you can actually get them to be more glycolytic. So they can create more ATP faster. They're just more fatigable because they're relying on a finite resource rather than oxygen.
Right. And so, how does this relate to endurance training? And
Mm-hmm.
really, I guess let's start like, let's define what are endurance sports.
Yeah. So this has been something that's actually been kind of a little bit illuminating to me, having conversations with you and some other people on my podcast, is like an endurance sport is anything that has repeated repetitions, right? Over and over and over, very low level. Like you're not going to be, if your deadlift maximum was 225 pounds, an endurance sport would be you lifting that deadlift, lifting a 40-pound deadlift over and over and over and over again for
So,
extended periods of time.
so if we could put like, could you put like a time limit on it, or like anything beyond this would become more of a, and the reason I say that is like, if we were to
Yeah.
say like a sprinter, like their training probably looks very different than somebody training for the 800 or the mile.
Yeah, I would even say like where you start to actually get into quote unquote endurance is like anything that's like 400 to 800 meters and above.
So in
Um,
seconds, what would that be? Like,
in minutes, it would be probably anything like 1 to 3 minutes or above.
okay, right. And so I know we're kind of getting off topic, but like, if you could paint a picture, like what does fiber contribution or energy contribution look like as we like those first like up to 30 seconds and then beyond? How does it change?
Yeah, so this might actually be more of an energy systems talk.
Yeah.
But so we have let's take a step back. When you exercise, when your muscle contracts, it needs energy. We get energy from the breakdown of the energy currency of the cell, which is adenosine triphosphate. And in order to actually liberate that energy, we break off a phosphate group, and then the release or the breaking of that bond releases energy, and it can be harnessed in the form of chemical energy or mechanical energy in order to actually like move the contractile elements of the muscle across each other, or it can be lost as heat. So so that's what our body is trying to do is trying to maintain ATP. And in order to maintain ATP, we have to have energy systems in place in order to regenerate ATP as fast as possible. So we have three main energy systems. We have phosphocreatine, we have glycolysis, which is the breakdown of carbohydrate, and then we have oxidative phosphorylation, which can use carbohydrate, fats, and in some cases protein, but we're really trying to avoid that. Pairing that with oxygen in order to actually make more ATP. The challenge is is that oxidative phosphorylation, or the process of using oxygen, has a lot of steps and kind of takes a little bit of time to generate that ATP. So during a sprint, for example, 0 to 10 seconds, 0 to 30 seconds, whatever it is, we are highly reliant on phosphocreatine and glycolysis in order to generate that ATP fast enough that we can continue to actually have that contraction to occur. Once we start to, so it's proportion of contribution during these time periods that you're going to see, like sprinting is generally glycolytic or phosphocreatine. Anything between 30 seconds and 2 to 3 minutes is going to be a little bit more reliant still on phosphocreatine, but glycolysis, and then just a little bit of aerobic metabolism within oxidative phosphorylation. Then really anything 3 minutes in extended is going to rely proportionally most on oxidative phosphorylation. So all systems are working at all times to regenerate ATP. It's just the proportion that you're getting that energy from is what we're worried about.
Yeah, and I think the reason I'm glad you kind of went off on that for a moment, because I think it's important that when we think about it, when we think about endurance training and what we're trying to do, you started by talking about these different fibers and what some of their characteristics are. And so if we think about the slow twitch fibers, they're kind of like the more endurance type fibers. And so if we're doing endurance events, then it would make sense that we're trying to train those fibers, right?
Right, exactly. So then how we can think about that is, at the end of the day, if we're trying to maintain a force output for extended periods of time, right? Because that's what endurance training is just prolonged force output, prolonged sub-maximal intensity force output for as long as we can do it. Then we start to think about, okay, now we have these energy systems, but those energy systems, so you can think of them as gas tanks. And within each muscle fiber, the size or the amount of those gas tanks is actually different. So in your type 1 fiber, the gas tank that is the absolute largest is your oxidative phosphorylation system, with very, very small contributions from phosphocreatine and glycolysis. Type 2A fibers are kind of your intermediate fibers. So they have kind of a mixture of all of them. So they can have phosphocreatine, glycolysis, and oxidative phosphorylation. And then your type 2X fibers have a really, really small capacity for oxidative phosphorylation, but have a very large capacity for glycolysis and phosphocreatine. So this is where kind of like fiber types come into play, right? So when you are doing endurance activity, you're trying to be as fatigue resistant as possible, and you're exercising at a submaximal amount.
Right.
So you are going to be using a lot of those type 1 fibers, and you're going to be highly reliant on your oxidative phosphorylation system, your ability to actually use oxygen to make energy. And this is why it's been identified. This is why VO2 max has been identified as one of the most important variables for endurance performance, is because it gives you the upper bound of your capacity to use oxygen. Then one step underneath that is, what percentage of your VO2 max can you maintain sustainable exercise intensity? And that's also going to be highly reliant on the amount of oxygen you can get to and utilize within the cell. And it's, in my opinion, endurance activity comes down to mitochondrial function and
Right.
your body's ability to actually utilize oxygen within the mitochondria. So you need to, so the whole reason why training improves mitochondrial function, improves capillary density, improves cardiovascular output, improves say type 1 fiber function or proportion if you're training long enough, is to get more oxygen to the muscle in order to maintain ATP contribution from primarily aerobic means for as long as you possibly can.
And when I asked that question earlier about like the contribution from each, once you like get to a certain point, I like, if I recall correctly, I want to say like at like 1 minute, it's almost like 50-50. like 50% aerobic and then 50% non-aerobic. And so like beyond that, like it's primarily aerobic, right?
Yeah. Well, so what's really interesting too is if you start to use things like NIRS or like muscle oxygenation, and you start to actually look at what happens to oxygen values immediately when you start exercise, your oxygen values immediately start to drop. So this is very counterintuitive because what we've been taught in exercise physiology classes, or just from what we've seen,
Mm-hmm.
from normal social media or whatever it is that okay, you have your anaerobic source, and then it transitions into kind of glycolysis, which is a little bit of a mixture,
Mm-hmm.
and then it transitions. It's like no, 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 no. All of these systems are always working together because they're so intertwined
Right.
that
Systems.
you're immediately upon the start of exercise your mitochondria are going as hard as they possibly can. They just might not be able to supply as much ATP as, say, the breakdown of creatine would be able to supply, or glucose glycolysis would be able to supply as well. So trust me, your body isn't like, no, 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 we gotta wait. We gotta wait 1 minute before we start to use oxygen. It's like, no, all hands on deck. We're trying to get as much ATP made as we possibly can. So even during a sprint, where if you ask somebody about traditional bioenergetics, they'd be like, oh, it's phosphocreatine first, then glycolysis, then
Mm-hmm.
aerobic capacity. If you're wearing a NIRS device like a Moxie, you will see your SMO2 plummet,
Right.
which is your muscle oxygen saturation. You'll see the oxygen absolutely plummet because your muscle is demanding a ton of oxygen to try to make ATP, but it can't make all the ATP necessary for contraction to occur. So then it starts to rely on the phosphocreatine and glycolysis as well.
Okay. And I don't mean for this to turn into an energy system talk, but we're going to keep coming back to it. And so I guess the way, like, so the charts that I've seen or the diagrams that I've seen, everything kind of overlaps where it's like
Yep.
there's a little bit of contribution from everything
Right.
at that 0 to 5 seconds. And then it like they ramp up and ramp down. And so, like, when I've explained this to athletes or when I think about it, the aerobic contribution, it's like getting a train up to speed, right? Like
Yeah.
it chugs, 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 and then so for like really like doing a VO2 max effort, so something like max effort for 3 to 5 minutes, it kind of takes a while to like get up there for that first one, but then we also see this like exercise post oxygen debt
Mm-hmm.
to pay back. And I think so it relates back to this is something that's like super interesting to me is like this idea of like always trying to maintain ATP. And so we cover that debt in the beginning with non-aerobic
Yep. With
sources.
phosphocreatine and to some extent glycolysis. Yep.
And then we finish, and then we have to kind of like, as we're trying to like replenish and like pay back that energy, that's why the oxygen stays elevated. It's
Mm-hmm.
because you're trying to like replenish that, correct?
Yeah. Yeah. And let's think about it this way too. Like the amount of steps that it requires for you to get oxygen from the environment to your muscle are actually like there's a lot of steps that are actually required to get
Right.
oxygen all the way to your muscle. So it takes time, right, to actually get your body to reach some level of homeostasis or steady state or equilibrium with oxygen delivery and oxygen demand. So there's that. And that's why I think, to some extent it takes some time to ramp it up. Phosphocreatine is a unidirect or a bidirectional equilibrium reaction, which means when ATP starts getting used, it's going to push to the side of supplying more ATP. And it's just one step. It's just one transfer
Right.
of a phosphate group. So that's super, super fast. And, so that's why we tend to use phosphocreatine right at the beginning of exercise. It doesn't matter if you're sprinting or it doesn't matter if you're just walking or something. Most likely because your heart and your cardiovascular system and your lungs and your ability and your capillaries and all of that sort of stuff have not come up to speed yet to deliver enough. So I want to bring this back to fiber types though.
Yeah.
And I do think a lot of people get a little bit over concerned with, oh, well, I don't want, I want to stress my fibers and the correct fiber types and stuff like that. It's like you can't really do that. By doing proper training, by doing zone 2 training, extended periods of time, you're going to stimulate pathways that are going to make your body more fatigue resistant, i.e., more type 1. And even if you do have a higher proportion of type 2A fibers, those type 2A fibers are going to start to look like type 1 fibers. They're never going to be type 1 fibers. Well, I can't say never, because there is some level of transition between the fibers, but they're going to from a training perspective, they're going to adapt to look and function more like type 1 fibers. And that's what it comes down to, is by doing more endurance training, your body is just going to kind of take on the phenotype of what you're trying to train. So it's not like, oh, I'm doing a type 1 fiber ride today, sort of deal. It's, oh, well, if I'm doing the proper exercise intensity, then my body is going to become more fatigue resistant. And one of the consequences of becoming more fatigue resistant, and it's a benefit, so it's not a consequence, but one
Yeah.
of the ramifications of doing more type, zone 2 training is that you're going to look like more of a fatigue resistant individual, which means you're probably going to have or look like you have more type 1 fibers, or your type 2A fibers are going to be more fatigue resistant, more mitochondrial dense, higher mitochondrial function, better ability to transfer oxygen from the capillaries to the mitochondria, so on and so forth.
Okay. So, what are your takeaways for muscle fibers? Is there anything we didn't touch on that you think is important to touch on before we
I mean, I think it's
conclude?
important to know, like the delineation between type 1, type 2A, type 2X, just because then you can kind of think about all this stuff a little bit more. But I think for the majority of people, I think if you are so in the weeds that you're like, oh, I am specifically taxing just my type 1 fibers today, is like you can take a step back, because if you're doing proper training and you have a coach that is properly training you, then the phenotype is going to follow, rather than specifically training like one energy system or one muscle fiber type, or something like that. I will also say too, and we'll talk about this in a subsequent episode, is that other than maybe your type 1 fibers, you can't specifically train one fiber type as it is.
Right.
So
And,
I'll leave them with that.
and I think my takeaway from this one is we talked about this in the training principles episode, which you can go back and listen to. But the said principle, so specific adaptations to impose demands, and
Mm-hmm.
we are what we repeatedly do. And so if you want to be a better endurance athlete, then you should probably practice endurance, and your body's just going to adapt. I guess the other thing is, like when you were talking about phosphocreatine, is our bodies are lazy. Evolution was lazy. It was trying to find the most efficient way with the least amount of energy expended so that it could survive. And so that's what our body does too. And so it's always going to, whatever you're doing the most, your body's going to find the most efficient way to do
Mm-hmm.
that. And that's essentially what training is at the end of the day, is just
Yeah.
getting better at whatever it is you're doing.
Yeah. Yeah, I 100% agree with that. And like I said, I do think it's important, but I think there are a lot of people who get a little bit too into the weeds of it. So it's like yes, it's important to understand what's going on in the black box, but at the end of the day, we do have larger physiological values and markers that we can measure in order to say, okay, those are probably a little bit more explanatory of increased performance, rather than, oh, well, I shifted my muscle fiber type.
Right.
Unless you get muscle biopsies like I was talking about earlier, then you're never going to know what your muscle fiber types are. You can just know kind of in general. Well, I've done a lot of endurance training, so I'm probably a little bit more, type 1 phenotype, or fatigue resistant phenotype, or oxygen, delivery and
Yeah.
utilization phenotype, whatever you want to call it. But yeah, I do think that it's, we don't have a way of actually measuring fiber types unless you go into a lab and get a muscle biopsy done at this point.
Yeah, and I guess just as another parting kind of thought here, I think in terms of practical application and how this impacts me as a coach, in my experience, like very few athletes are more of that fast twitch. Like let's say 30% of my athletes are more of that fast twitch dominant, and that will come through in like when you were a kid, if you won a lot of sprints, or
Yeah.
like if you're looking at power data, you'll see that they have a lot of top end power. And the only way that impacts me as a coach is that I have to be more conscious about when I'm having them do shorter efforts, is that they can go really deep and they can like put themselves in the box.
Yep.
And as we're like, I think it has something to do with our tapering too, is that like we might have to approach it a little bit different than I would with somebody that doesn't have as much top end power or short duration power.
Yeah. Yeah. And that is a really good point, because that is where I think this could be potentially useful, are people who have a tendency to have, just better power output on the top end, or like other things like that, have a tendency to not be able to recover as well. Like for some reason, it seems like if we lump them into fast twitch athletes, just need more time to recover, then that is something that you as a coach or you as an athlete could take away from this, right? You still won't ever know, right?
Right.
You'll never know, like, oh, I actually am more fast twitch or more slow twitch dominant, whatever it is. But I think from that perspective, you can do some field tests like sprints, or, like how far they fall off in their performance.
Yeah.
Like if you have an athlete that can sprint 2000 watts, but then they can barely hold 300 watts for 5 minutes, that's probably an indication, A, that they haven't done enough endurance training in the past, or B, they are so freaking powerful that they can just wreck themselves on like the shorter side of this the endurance spectrum, and need to again still work on the specific stuff. Like if you're a 6-hour racer and you have 2000 watt power but can only hold 200,
Right.
then you need to balance that out by doing less sprint stuff and doing more endurance stuff. So it comes back to specificity of training at the end of the day.
Exactly. And that's exactly what I would say too, is that like really it's about preparing for the demands of the event. And
Mm-hmm.
so, yes, you have to take these things into consideration. But at the end of the day, you need to ride your bike 6 hours or whatever that event
Yep.
happens to be. So, anyway, thank you very much for this episode. I think it was really good. I know I got something out of it. Where can people find you?
Yeah, so you guys can always find me on Instagram. That's the easiest place to reach me, at Critical02. If you have any questions, comments, want to learn more, head over there, and just interact with me on that, and I'd be more than happy to help guide you in terms of physiology, or any sort of training questions that you have.
Awesome. Thank you very much.